Right now, think about the song that gives you chills. Really think about it. If your arms just reacted, that's not a coincidence. Goosebumps show up for two completely different reasons, one you'd expect and one that still puzzles researchers. Every hair on your body sits inside a tiny muscle called an erector pili muscle, attached to the base of the hair follicle. When that muscle contracts, it pulls the hair upright and tugs the skin around it into the small raised bump we call a goosebump. This reaction is controlled by your sympathetic nervous system, the same network responsible for your fight or flight response. That's why goosebumps often show up alongside a racing heart or a sudden chill down your spine. They're wired into the same emergency system. The whole reaction takes less than a second and you have zero conscious control over it. Much like blushing, it's an involuntary signal your body sends without asking permission. To understand why we have this reflex at all, you have to go back to a much hairier version of humanity. In animals with thick fur, raising the hair traps a layer of warm air close to the skin, a built-in insulation layer against the cold. Standing hair also makes an animal look larger. For a threatened creature, looking bigger can be the difference between a predator backing off or attacking. Modern humans lost most of our body hair over the course of evolution, but the muscle, the nerve pathway, and the reflex never disappeared. In other words, goosebumps are a vestigial reflex, a leftover instruction from a body plan we don't have anymore. You can still see the original, fully functional version of this reflex all over the animal kingdom. A frightened cat arches its back and puffs out its fur, instantly looking twice its normal size to a threat. Porcupines and hedgehogs take it further, raising sharp quills using the exact same type of muscle contraction. Birds do a version of this too, fluffing their feathers, both to trap warmth in the cold and to look larger during a confrontation. Every one of these animals is running the same basic hardware we are. We just lost the fur that used to make it useful. Here's where it gets strange. Goosebumps don't only show up when you're cold or scared. A powerful piece of music, a breathtaking view, a speech that hits exactly the right note, all of these can trigger the same physical reaction. Scientists call this an aesthetic chill or frisson, a wave of goosebumps triggered by emotion instead of temperature or fear. Nostalgia can do it too. A song from your childhood, an old photograph, the smell of a place you haven't been in years, sudden, unexpected emotional weight, and suddenly your arms react. So can reunion and loss. Seeing someone after years apart or hearing news of someone's passing can trigger the exact same physical wave. Roughly half of all people experience frisson at least occasionally, most often during music that builds unexpectedly or shifts emotionally at just the right moment. Unlike cold-triggered goosebumps, frisson often comes with a distinct feeling, a rush, sometimes even a chill running down the spine or scalp. Researchers have found that people who experience frisson tend to score higher on a personality trait called openness to experience. Openness is linked to deeper engagement with art, music, and abstract ideas, exactly the kinds of experiences that trigger emotional chills. Brain imaging studies have found something even more specific. People prone to frisson show stronger neural connections between the brain's auditory processing regions and the regions that process reward and emotion. In other words, in some brains, sound and deep emotional reward are wired unusually close together. There's also a timing pattern. Chills tend to hit at moments of musical surprise, an unexpected key change, a sudden swell in volume, a held note resolving exactly when you didn't expect it to. Researchers call this violated expectation. Your brain predicts what's coming next in a pattern, and when reality breaks that prediction in just the right way, it registers as significant enough to react to physically. That tighter wiring, combined with a perfectly timed surprise, may be why a single swelling chord can hit some people so much harder than others. This raises an obvious question. Why would powerful emotion trigger the exact same physical reflex as fear? One theory is that awe and fear share more ancient circuitry than we'd expect. both are the brain's way of flagging something as significant enough to demand your full attention. In an ancestral environment, that might have meant a predator, a rival's dominance display, or a sudden storm, anything demanding an immediate whole body response. Modern life gave us new sources of that same significance: music, art, meaningful memories, and the ancient alarm system never got the memo that the danger isn't real. So it fires anyway, using the only physical vocabulary it has: goosebumps, a chill, a moment of full body attention. Long before anyone understood the biology, people across history had a word for this feeling. The medical term for goosebumps, horripilation, comes from Latin horrere, meaning to bristle, and pilus, meaning hair. That same idea shows up across many languages and centuries: hair standing on end, a chill down the spine, skin crawling. Different words, same ancient bodily signal. Writers throughout history reached for this exact image to describe overwhelming fear or overwhelming wonder, long before anyone could explain the muscle behind it. That's a strong clue this reflex isn't a modern quirk. It's been recognizable and meaningful to humans for as long as we've had language to describe it. Not everyone experiences frisson, and that's completely normal too. Some people almost never get emotional chills, regardless of how moving the moment is. Age plays a role. Some research suggests the intensity of frisson responses can fade somewhat as people get older. Familiarity matters as well. A song you've heard hundreds of times often triggers fewer chills than the very first time you heard it. The element of surprise seems to matter. Sleep and stress matter too. Being exhausted or emotionally drained can blunt the response, even to something that would normally trigger it easily. Musical training seems to play a role in the opposite direction. Some studies suggest trained musicians report frissons slightly more often, possibly from noticing more of the subtle shifts that trigger it. Mood and context matter too. The exact same piece of music can trigger chills on one listen and nothing at all on another, depending on your emotional state going in. Modern media didn't just stumble onto this reaction. Composers and filmmakers learned to engineer it deliberately. Certain chord progressions, sudden orchestral swells, or a held silence right before a musical climax are specifically used because they reliably trigger frisson in large audiences. A related but distinct phenomenon, ASMR, uses close, quiet, textured sounds instead of swelling music, but taps into some of the same tingling, full-body attention response. Even filmmakers use this science on purpose. A perfectly timed swell of music under an emotional scene is engineered frame by frame to land exactly when your brain is primed to react. In a strange way, an entire modern industry has been built around deliberately triggering an ancient reflex that originally had nothing to do with entertainment at all. So the next time your arms prickle during a song or a view takes your breath away, remember what's actually happening. You're running ancient hardware, built for a body covered in fur, repurposed by your brain for something it decided was just as significant. It's not a malfunction. It's your body's oldest way of saying, pay attention, this matters. This channel digs up one forgotten why every week, the hidden reasons behind things we do without ever asking. Subscribe, and next time, we'll ask why we cry happy tears at the exact same moments we'd cry sad ones.